Hey, what's up, Math 1? Welcome back. Another episode, another lesson of Room 1809, Math 1. So here we go. So we have been working on equations and inequalities and proportions. And most of those equations have had one variable. But now we're going to transition into equations that have two variables. So this is a real short introductory lesson. It's just a one-page set of notes that I'm going to have you take, and I'm going to explain the difference between a one-variable equation and a two-variable equation. So let me go ahead and flip over to the DocuCam. We'll go ahead and get started. Okay, so you should have these notes in front of you. So one variable versus two variable equations. So when we talk about a one variable equation, I've got a few examples here. So the first example is just a real simple 5x minus 3 is equal to 17. Now, we're not even going to take the time to solve it. I just want to point out there's one variable, right? There's one unknown. It's right there. It's the variable x. If we were going to solve this, this should be pretty simple for you at this point. We would add 3 to both sides. That would make this a 20 over here. We'd have 5x equals 20, and then we would divide by 5, and x would be equal to 4. So, but we're not solving it. I'm just giving you an example. So this is a one variable equation. Okay, now here's a second example. On this one, this is still a one variable equation. We've got the variable x. It happens to be in two different locations, but this is still considered a one variable equation. All we would need to do is we'd need to just combine like terms. Okay, so you can see we've got 3x plus 20, and then over here, this would be our fence right here. Right, we have a fence, and we over here is 7x minus 4, but it's still the same variable. So if we were solving this, the first thing that I would do is I would subtract 3x from here, and I'd subtract 3x from here, and we would cancel this out. So it's still just one variable. So the note that I want you to write is that I want you to just put on this one, x is the only variable, right? It just happens to be in two locations. So it's still the only variable. All right, so take a moment to copy that down, or you can pause the video. Okay, so those are one variable equations. It doesn't matter which variable. You could use the letter Z, or you could use a D for dog, or C for cat, whatever you want. Just one variable, okay? Traditionally, we use the variable X. Now, when we look at what we call a two variable equation, on a two variable equation, here would be an example. So traditionally, if we are using two variables, we would use the variable x, and then we'd also use the variable y. So this is a two variable equation right here. Okay, this is actually called what's called standard form. We'll be learning that later on, but that's called standard form. And now here's another example right here. And this one is one that a form that you should be familiar with. It's called slope-intercept form. It also has two variables. So we have the y variable here, and we have an x variable. This is 20 times x, and then over here, this is called the y-intercept. We'll get to that in the future as well. We're just looking at two variable equations. Now, when you have two variables, this is called, when you have two variables, we call this a linear equation, a linear equation. Okay, so go ahead and write that down. Now, the reason that we call it a linear equation is because when you have two variables like this, we graph these on what we call a coordinate plane. And I know you've seen this before, so this is just a review lesson. You've had this in the past. So a linear equation, you have your x-axis. This is called your x-axis, and this is your y-axis. And this is a linear equation. You can see the word line, L-I-N-E, the word line right there, L-I-N-E. So, and it's making a straight line, and it's crossing the x-axis right there. We call that the x-intercept. This is called the x-intercept right there. The x-intercept. And this one right here is called the y-intercept. And that is where the line is crossing your y-axis. So that would be the y-intercept. Okay, so you have x-intercept and y-intercept. Okay, a few more thoughts about these linear equations. This is what we're going to be transitioning to working on. We're going to be working on these two variable equations. Often, when we have two variables, we have those equations involve what we call a rate. Okay, a rate. And so I just want to talk a little bit about rate word problems. The next lesson that I'm going to give you is a strategy called the 3-box strategy, which I'm going to, we've talked about a little bit, but I'm going to go over it a little bit more in depth. But a rate word problem, it usually involves two variables. Okay, so go ahead and copy these notes down. They usually involve two variables, an input, that's your x variable, and an output, which is your y variable. So you have what we call the input. This is where we plug numbers in, and then this is our output. And we're going to talk more about that in the coming days. Also, a couple other things about rate. Many word problems involve a rate. So often, and a lot of the word problems that we're going to be doing will involve a rate. So we're going to practice these rate problems. And so what do I mean by a rate? Well, what I'm talking about, like here would be some examples, right? If we said the price per movie ticket. So if you're going to go to the movies, it depends on what movie theater you're going to, but it might be $12 per movie ticket. Okay, $12 per ticket. When you see, when we're looking for a rate, we often have this word per right here. Okay, so this would be price per movie ticket. Here's another example, miles per hour. So when we measure how fast we're driving in a car or on a motorcycle, we would say miles per hour, right? We got the word per, so this is a rate. Speed is a rate when we measure speed. If we were talking about in baseball, a pitcher throws 100 miles per hour, right? That's his rate. That would be how fast he can throw a baseball. Here's a couple others for those of you that are starting to have a job. So an hourly wage. So you might make $15 per hour, $15 per hour. My two sons, I pay them, they help me with yard work. I pay them $6 an hour. So that comes out to $1 for every 10 minutes. But that's their hourly wage, just $6 per hour for chores, helping me, mowing the lawn and things like that. So this would be a rate, an hourly wage. Then here's another example, a rent payment. When you move out on your own, one day you'll be hopefully not living with mom and dad. And when you move out, you probably rent an apartment to start off. Usually people don't have enough money to buy a house, so they rent an apartment. I rented an apartment before I had enough money saved. So your rent payment is a rate. So it might be $1,000 per month, $1,000 per month. Okay. A couple other thoughts here about rates. When we talk about rates, you want to look for the word per. Now, sometimes in a word problem, the word per is not actually in the word problem. You have to kind of read and look for the meaning. So it might not actually have that word. For example, it might say, Jose makes $15 an hour. Well, it didn't actually put the word per in there, but $15 an hour means $15 per hour. So that's how you know that you're dealing with a rate. Okay, and then the other thing is a rate is a ratio. Okay, a rate is a ratio of two categories. So you're comparing one category to another. So what do I mean by two categories? So let's look at this example again, miles per hour. So we're taking distance, this would be miles, and we're comparing that to time or hours. So this would be one category, and this would be your other category. And then over here, this would be one more example, dollars or money per ticket, right? So this could be a movie ticket or a concert ticket or a ticket to the Laker game, right? So money per ticket, okay? So that's a little introduction. The main thing that I wanted to focus on was two variable equations. So two variable equations, we're gonna start looking at that. And then I also wanted to introduce the concept of a rate, concept of a rate in word problems. Okay, all right, so go ahead and finish those notes up. That's a short one, and I will see you in our next video. All right, let me close this out, and okay, so I'll see you guys. You guys have a good good day. All right, bye-bye.